Welcome. In today's episode, we'll discuss variables and data types in Python and Grasshopper. Let's get started. Let me share the screen. Okay, so we are in Rhino. Just a little bit of an introduction about the interface. We have a scene, a 3D view in the middle. We have layers on the right, and you may already also have the properties panel docked on the right. I just moved around a bit the panels to customize it, but they do the same functionality. I won't go through and explain everything about the Rhino interface, as is not the point. During the different videos, when I use a command in Rhino, I will just explain what it is so that you can follow along. What interests us at the moment is just this Grasshopper component, which launches Grasshopper. It's in the standard bar, and you can hit the button. Another way to call Grasshopper is you can write Grasshopper in the command line down here, and it will fire up. You probably have the command at the top, but it's the same command. All right, then another thing is when you close Grasshopper, so if you do close like this, it doesn't actually close it, it just reduces it. So if you click on it, it just brings it up again without asking you to save because it's not actually closing. If you want to close a file, you have to click on the name of the file and this X icon, and in that case, it will ask you what you want to do. In this case, I will not do anything. Just some introduction about the interface of Grasshopper as well. At the top, we have this classic Windows menu with the file edit view commands. And then we have these tool sets with buttons that you can click to bring components on the canvas. So the canvas is this main thing at the center where we will do most of our job. Then you have categories. So these are the categories, and each category is subdivided into subcategories, and each subcategory has a panel with all the components dragged in. We will eventually learn how to add our own commands to these toolbars and how to install external plugins. But at the beginning, let's just dive into what's available in Rhino. So the first thing we want to deal with today is data types. Before we do that, let me just introduce you to a component which will make heavy use, this Python 3 script. So let me click on that. If you just hit the spacebar or you double click on the canvas, you can search for the component names. So in this case, you can write Python, and you'll be prompted to choose between two different versions of Python if you're using Rhino 8 and ahead. If you're using Rhino 7, you'll just have one type of Python, which is corresponding to this Python 2 script. In this case, we go with Python 3, which is a more complete suite of Python. Which version of Python it is? Well, it's a specific 3.9.1, I believe, version, and it's just stuck to that, so you cannot update it. And it's not the same as a Python you may already have installed on your computer. It's a version that only works in Rhino Grasshopper. And in fact, let me show you where it is saved. If you open up your local disk, you can go to your users. So users, then your username. And in here, you will find a folder called .rhinocode. Let me find it. There it is, .rhinocode. And inside here, you have two installations of Rhino. One is Python 2.7, one is Python 3.9. So this is the Python 3.9, which we are using when we call the Python 3 component. If you call Python instead, you're using this installation. As I said, you can't update it. It only works with this version. McNeil will update probably to new versions in the new version of Rhino, and maybe let us switch Python version. Who knows? At the moment, we are stuck with 3.9, which is still a pretty recent flavor of Python. You also have the configuration file here, pip.ini, and you can use this maybe if you have a corporate proxy that's locking connections to just write that and to like configure Python as traditionally you would. And then here you also have the site ems, the site like the libraries, the additional libraries, everything gets installed in here. Okay, so let's go back to Grasshopper. If you double click on the Python icon, it will open up an IDE, and you'll have like a text editor at the top. You will have a terminal, an output terminal at the bottom, and then we will discuss maybe the other commands in the future episode when we discuss plugins compiled directly from Python, from Rhino. But at the moment, let's just start with the topic of today. So data types and variables. Okay, so let me dock this to the right. So let's create our first variable. Let's call it x equals maybe a number 3, okay? And you'll notice that I'm using this equal operator. This doesn't mean it's not an expression. It's not asking if and when x equals 3. It's an assignment operator. So it's kind of like if it were like an arrow. So we're taking 3 and we're putting it into the 3 variable, but the syntax is just this equal sign. And we can create a bunch of different types. So this is an integer. Let's go integer. Then we have maybe a string. Let's write hello. You can also use, of course, the letters. So hello. You can have characters. Let's say C equals maybe A. And you can write strings and characters in 2 different ways. You can use the double quotes or the single quotes as you prefer. As a good practice, you could decide to use the single quotes for characters and double quotes for strings, but it's really not enforced. Python allows you to do, to use both of them in the same for the same type. And there's not actually a character type in Python. They're both strings. So let's write that. Let's say this is a string. And what I'm doing here is I'm writing comments. So comments are this hashtag symbol or the diamond if you prefer. This is also a string that is containing just a character. Okay, then we have other types of booleans. So let's say B is true. And of course we could have also maybe D is false. Okay, these are the booleans. And they're storing a value which is either true or false. And you could also use numbers for this. So this is a boolean. And we could write could also be a number. In this case, true, it's a number like that is not. So it's different. Different is like this than 0. And false is actually another boolean. Could also be a number, an integer specifically, actually maybe any number that is equal to 0. So if you write 0, that's interpreted as a false. If you drop it to some place where it's expecting a boolean, if you write any number which is different than 0, it's going, or actually any value which is different than 0, probably even a string at that point, it would be interpreted as true. Okay, and so these are the basic types. Actually, there's one last. Let's call it F. Is maybe 3.14. Okay, so this is a float. It's still a number, but it has floating points that defines the integer part and the the decimal part. So this is a float. All right, so these are the basic types. Let's use and introduce our first function. An inbuilt function. So a function is a name and then parentheses to call the function. We will learn how to create our own functions. At the moment, let's just create this function which is already available in Python called print, and we may then write the name of a variable and hit the either Control S to save. That will trigger the run, or you can just click this green play icon and that will also run. So you can print X, let's maybe print C. All right, so this is just printing the character. You could, of course, already also print the value directly. That will just work as well. And you can also ask the type of the different things. So there's another function. Let's store it in a variable. Let's say maybe say type underscore off. And the function is called type. You see that it highlights it in blue when you call an existing function. And then we ask the type of X, maybe the type of X. And then we can print type off. Type off. All right. And you'll see this is an integer. And it's telling you class int. That's because class is sort of a way to say type in Python and also in other languages. And you can also create your own classes and extend the basic types available in Python. And in fact, Rhino already did it. So you will find that if you use Python within Rhino and Grasshopper, as we are doing, you can also use other classes than the basic types. We will first see the basic types and then see which other types we have available. So of course you could also like concatenate the two functions. So you write one inside the other and that would still work. So this is an integer. Then let's just print s, that is a string. You'll see that c is a character, but it's actually just a string. So there's no specific type for a character. And then you have a boolean and then you have a float here. Okay, just something about naming conventions. Usually in Python we write words all like lowercase with underscores that separate the names of the variables, and this is called, I believe, snake case, because it's sort of like a snake, like an S shape of a snake, and you can create single letter for variables. You can't put numbers in front of the variable. You can put it after the first character though. All right, so, and I believe, and of course, you can't put dots in it. You can put underscores or dashes instead. This you can do. Of course, you have to do. Actually, dashes probably you can't. Yeah, you can use underscores. All right. So let's see how to use these basic types in Grasshopper as well. So you'll find that in the parameters, the first category, you have this primitive thing, and here you have some components. You could either write like here number, for example, and that will get your number. Otherwise, you can, if you know where it is, you can click the menu directly and hit number and drop it in. And if you have already a component on the canvas and you want to know in which panel it was, you can hit Control and Shift and then click on the object. I believe it's Control Shift. Probably not. Actually Control Alt. So Control Alt and you click it. You see it becomes an eye icon, and then if you click, it will tell you where it is. And if you are in a different tab, it will move to the right tab and show you where it is. All right. So let's actually close this Python module, and let's start with all the same basic types. So we have an integer, we said, we have a float. It's actually defined as a number here, but it's the same, it's a float. Then we have a boolean, which is called the same way, and then we have strings and characters, which are defined in this text parameter. And then there are other types like dates, like complex numbers, like colors. We're not going to deal with this at the moment. The only one I care about is this data, because it's sort of a wildcard. We will see it. We will see it just in a second. Let's just add actual values to these values, to these components. So in order to set a value, you can do it in several different ways. One is right-clicking on the component and setting the integer. In this case, we can write 3 and then commit changes, and then this will store the value 3. And then you can inspect the values by using this panel object. So you can spacebar to look for components or double-click on the canvas, and then you can use this double quotes. That's like calling panel, or you could spell panel completely, and that would work as well. So then you can hit enter, and that will bring your a panel to the scene. And this is a way to either write values in or get values from nodes. So any node has an input and an output, or maybe more inputs and more outputs. And in this case, let's take this output and drag it into the panel input, and you see that we have 3 as a value. So we can do the same thing with the float. So let's do 3. I believe I did 3.14 in Python. It doesn't have to be the same, but let's just stick to it. And then we can do hello, which was the text. So right click, set text, hello. And then we have booleans. So right click, set boolean, let's say true. And there we have it. So these are all the different types we have available. And here we have a difference between Grasshopper and these are the same. I mean, between Grasshopper and Python. There's one thing which is different, and in that in Grasshopper you can actually like enforce types. Let me show you what it means. Let's say this is an integer. We said so. Let's make a copy. Let's create another integer here. Okay, and let's say we want to use, instead of writing it that way, we want to input a value from a panel. So let's say hello is our integer, and then we drop it into the integer. You will see that it shows you an error, and it says this is a text. You can't convert a text to an integer, and it will also probably actually give you null. So this is not allowed. This will not happen in Python because Python doesn't enforce types. So you see that in this case, x contains an integer, but a heading code, I could do x equals hello. And then if I print the type of x, this is not necessary anymore. You will see now it's a string and it didn't give you any error, or you could print the x value directly and that's now a low. So as a variable, it's not enforced to contain any type. It can be an integer and then change to a string later on in code and then change to a boolean and do whatever. Instead, in Grasshopper, if you use this kind of variable holder, then it's not gonna allow you to do that. So it's sort of like a typed language, if you like, because Grasshopper under the hood is really using C#, which is a typed language. But we will see C# probably in a more advanced level of these videos. Though there's a wildcard, so there's this data thing, and this data thing behaves kind of like Python, so you can drop whatever you want in it. And let's do that. So let's say it's 3, so this is now an integer. And otherwise, if I write hello, this will become a text. So you see, I'm not sure you can check types. Yeah, you can't check types, but whatever. This, if you hover over it, it shows you that this has actually become a text. So you can change any value to it. You can also write true, and this is now Boolean. So this is a generic holder. All right. So now that we saw these generic data types, let's go and see the specific types that have been added to Grasshopper and Rhino through classes. Again, we will see classes, like create our own classes in the future. At the moment, let's just check out some of the classes that are available in addition to Python. So they would not be available if you just used Python on your computer. But since we are using a special version of Python, which is embedded in Grasshopper, we have access to some other types as well, so not these basic ones only. Actually, let me show them before in Rhino and Grasshopper, as it's easier, and then we'll see how to do them in Python later on. So let me actually delete this, we don't need it. And these are still in primitive. Actually, they're here in geometry because, of course, Rhino is basically a CAD software. So what the data types specific to Rhino are mostly geometries. So let's split the screen in this case, and I will show you how Grasshopper and Rhino actually talk to each other and all support the same or mostly the same data types and use the same library underneath. So let's create a point. So this is hold point. You can right click, set one point, and then this will prompt you to define a point on the Rhino canvas. So we'll click it, and now this is a point. So the point is a point 3D, contains 3 coordinates. We will talk about these geometry types specifically. We will do a video for each category, but at the moment I just want to show you that you can store these kind of values and just go through them. So you have a vector as well. You can set one vector. Let's drop that in. Okay, so this is a vector. You can actually preview the vector because it's not by default. So we can go to display, vector, we could write this one, and then I will also create actually I will probably move this point, use this point as an anchor, and you see we define the vector and we're visualizing it that it starts from the point we defined and it's moving by the amount that we defined with the vector. All right, so this is just a way to preview vectors around. So let's go back. Let's say we want to define a curve. Let's say we have maybe a mesh. Let's use a brep as well. And I would also do a surface. So these are the basic types that we will use throughout the code. If you select them all, you'll see you have these handles, and you can maybe click this middle one to align them on the canvas. That's a quick trick. Okay, so you could define these curves directly in Grasshopper, and we will see how to do this stuff in Grasshopper in future lectures. At the moment, instead, let's draw them in Rhino and then call them and assign them in Grasshopper, because this is a powerful thing you can do. You can draw stuff in Rhino. The Rhino file kind of stores like a database, stores the geometry in a file, and then you can access that database in Grasshopper to process it to process it somehow. You could also save stuff in the Grasshopper file, but it's usually not advised. So let's define a curve. So what's the curve? Actually, could be a line, it could be like a straight line or a dip or NURBS curve. We will see what a NURBS curve is, but at the moment, let's just draw one. So I'm using this in the main toolbar. I'm using this control point curve components command, and then you can click a bunch of points. So let's draw 4 points, and this is now a curve. And you see, if I go back in Grasshopper, I can right click and set one curve, and it's not going to prompt me to draw a curve, but to actually select one. And I can do it like that with a selection window. And now here we have a reference planar curve planar because it's in the plane. You could also have non-planar curves, and it would just use the same element. Let's just draw a surface now. Let's a surface. So we could go to surface tools and draw. I mean, actually, you could do it from the standards from the main as well. So let's draw a surface. Let's say we want to draw a very basic surface. So it's going to be a flat surface. In this case, you could also have curved surfaces, but we will deal with those in a more advanced lectures. Let's now bring back Grasshopper, and you can do right click, set one surface, and indeed you can select a surface. Just since we're here, let me just show something. You see you have a preview. The preview is red when you don't select the object. It becomes green when you do. This is defined in this document preview settings. You could change the colors if you want. And the other thing I want to show you is if you close Grasshopper, so it's actually minimizing Grasshopper, this preview goes away. But if you bring it up again, like it's just minimized, it won't lose what you're working on, unless, I mean, Rhino crashes. In that case, if you didn't save the file, you'll probably lose it. There's a note to save feature, but don't rely too much on that. And you can also, by hitting this arrow right here, or by using this display mode in the properties, change the properties of shading of the canvas of the 3D scene in Rhino. Let's stick to wireframe at the moment. Wireframe just means that if you have two objects overlapping, you see also the one behind without problems. And the other thing you probably see, actually now, I guess the preview is glitched. Okay, let's reassign it. But what I wanted to show you is that if you move objects around, they will still be understood by Grasshopper. So if you move it in Grasshopper, sorry, in Rhino, then it will stay attached to the object that you attached it to. So let's do now a brep. So what's a brep? It's just a bunch of surfaces stuck together in a single object. So it can be either open or closed. Let's use maybe this box command, and this will create 6 flat surfaces. And indeed, this is just a brep. The reason it's called a brep is because it stands for boundary representation, because this is sort of like a solid, but it's not actually filled inside. It's just represented by the outer surfaces that make it up. So let's just right click here, set one brep, and indeed we can do that. I will also show that this also enforces type as the basic parameters did. So let me right click and clear the values, that will disappear. And if I try to set one brep and select all the scene, let me wait a second. It didn't work for some reason. Let me clear it. Set one brep. Let me do that. For some reason it's not working. I mean, on your version it should select the brep. Even if you use the window, there's probably a bug of some sort at this stage. It doesn't matter anyway. If you drag select, it would only allow you to, maybe let's try to drag select on the other direction to see if it fixes that. Set the brep. Okay, in that case it works. So let's do that. So clear values. This is empty now. Should be empty. Let's bring up a new one. Brep. All right, so set one brep, and if you drag over all the scene, it will just select the brep. It will not bring up the curve. It will probably instead accept the surface and convert it to a brep. Anyway, this enforces the type as well. And then we have a mesh. So in this case, I don't have a mesh at hand to to import. So I will just create a brep and then write the mesh command in Rhino and convert it to a mesh. So mesh, okay. And then in here, I will delete the brep. And then we have mesh here. So it also in Rhino, when you click, it tells you what you have selected. In this case, is the mesh. You can also pre-select the object and then do set one mesh, and it will just automatically assign whatever you have selected if it's of the right type. And a mesh, it's similar to a brep, but a brep can have any surface, so flat or curved surfaces, as making up its shape, whereas a mesh has only flat faces, and these faces can have 4 or 3 vertices um, within them. So they're quads or they're tri elements. And this is used in a variety of exchange formats like IFC, and we will see that in the future. It's very widely used, but brep, it doesn't lose precision. So if you can stick to breps, it keeps better the geometry. A mesh, it's easier to exchange with other softwares. All right, and as you can do with basic types, with this you also have geometry. Geometry does not enforce the type, so you could do, in this case, let's select multiple geometries, and if I drag select on all of these objects and I enter, you'll see the geometry can contain a mesh, can contain a brep, can contain a surface, and contain a curve, and it doesn't enforce type, whereas if you do it with these components and you drag select, it will only see the object of its type. So now that we saw this in Grasshopper, let's go and check it out in Python as well. We can create types in here, or we could like take them from the Grasshopper scene. So let's do it in both ways. Let's delete one of these outputs and just also delete this. So we only have an input, and then we have this X. We can drop something in X. Let's say we want to drop one of these, which we already selected. Let's drop a surface in, for example, or maybe let's drop the mesh because it's maybe more interesting. So let's drop a mesh in. Okay, let's do that. And then if you just print X, you will see, well, a weird number probably. Okay, you will see this GUID. This tells you like the DNA, sort of like the code of this object in the RhinoDB. Otherwise, if you want to see the object and not its weird name, you can right click on the input, go to type hints, and then set the right type. So in this case, it's a mesh. All right, and then if you open up again and you print it, it will now recognize it as a Rhino geometry mesh. So what is this rhino.geometry.mesh? Well, mesh is the type, so it's like integer. It's like, actually, let me write type function so you can see it more clearly. All right, so it's a class of type mesh, and it's part of the Rhino geometry module. So how you can find out which objects you have, you can go on the web, and there's this, you can look up Rhino Common. So if you look Rhino Common on Google, it will bring up an object. So in this case, we can search for a mesh. There we go. And here you have a Rhino geometry module. So the namespace, rhino.geometry. And then this class is called the mesh class, which is the mesh type. And on the mesh type, you have some functions defined, but we will see this in the future. It's not the topic of today. Let's just see that you can also create maybe stuff directly in Python without accessing it from Rhino. Of course, you could do it in Grasshopper as well. Let me show you in Grasshopper first. We will only do the example of a point. So if you write x, y, z, this will have a construct point, and this will create a point. And indeed, if you look in Rhino, you see you have a point that has been created, x, y, z coordinates. By default, they're 0, so it's at the origin. And you could drop in maybe an integer as the x component, and you will see that this is actually having the result of that x component. And indeed, since I'm using this slider, let me also discuss a little bit this slider. We already discussed the panel as an input method. So in this case, we could write numbers in. So we have 3, or you could write strings and stuff. We also have a slider. So a slider is containing numbers. It can be either integers or or float. So you could do 3.12, that would be fine, or you could do 2, and that is fine as well. And you can set different parameters on sliders. So if you double click on the name number slider, you can change it. So you can write this is Z, for example. And you can also define the type. So it's a real number, so it has digits, or it's an integer. You could also do the exponential like notation, or these I'm actually even and odd numbers, not exponential. So no, natural numbers, real numbers, or even and odd. And then you have minimum, maximum, and range, which define like this, the range of the slider. And you also have this number of actually in the float one, you have the number of digits. So in this case, it's 3, 4, or whatever you want. And you can also write these numbers without actually doing it directly in the interface. You could say 3, and then let's say we want a slider which starts from 1, 2 points, goes all the way to 2, and then it goes actually it has a step of 2, so each 2 numbers. I don't think I can do that, actually at 1, and then it ends at 10. Sorry, this middle number is the one you want to set as default, so let's say 3. So this slider starts at 3, it goes all the way to 10, and it has 3 as a default value, so let's enter that. And indeed, this is something that starts from 1, goes to 10, and it had the value of 3 by default. And you can also do it for decimals. So if I write 3.14, maybe 145, and then 10, it will set that value, and it will also set the number of digits to the number you wrote. So in this case, we wrote 3 digits, so it decided that we had 3 decimal places. All right, so enough about sliders. You can actually, let's use these 3 sliders to drop them in the coordinates right here, and you have a point. So this is a type of point you can create. All right, let's go back to Rhino. Let's create one point. So let's say P1, it's a point, and we will do Rhino dot geometry dot point 3D, which is the name of that point. And you need to import the Rhino module to do that. So let's do that. Import Rhino. Okay, so now Rhino is recognized as a word. And then you have point 3D, and we have 3 coordinates. Let's say 3, 5, and 1.3. 0.3. And in this, we created a point. So this is and we can print it as well. So let's do that. The type of P1. So this is Rhino geometry point 3D, right? And we can also print P1 directly. Let's do that. P1. And this is by default, if you print a point, it would print the coordinates of the point because of the way the class is defined. Okay, so I guess that was enough. Yeah. Okay, so that was it for today's video. Hope you find it interesting. Leave a like, subscribe to the channel for more, and see you next time. Bye.